Hey guys, this is Solid Figures Day 1, first lesson of our new unit. This lesson is going to be a lot of me telling you definitions and you filling in the blanks on your notes page. You kind of need your textbook for this lesson, for the Toyos at the end. If you don't have it, you can probably copy the slides that I have onto a piece of lined paper and you'll be fine, but it's better if you have your textbook. All right, pause the video at any time to make sure that you have time to fill in your notes. All right, we're going to start with some definitions. What are polygons? A polygon is a closed plane figure with straight sides. Some examples are rectangles, squares, and triangles. Polygons are two-dimensional figures. So you could probably draw that yourself right now, but just in case, I'm going to show you some pictures. Go ahead and copy these into your notes so that you have a visual reference for what a polygon is. A polygon is not a specific shape. It's just basically any shape with straight sides. A regular polygon is a polygon in which the sides are all the same length and are symmetrically placed about a common center. For example, a square and an equilateral triangle are regular polygons. Here are some pictures of regular polygons. So what would not be a regular polygon would be a rectangle or a triangle with sides that are not equal. A polyhedron is a three-dimensional solid which consists of a collection of polygons joined at their edges. This sounds a little bit complicated until you think about taking a polygon and making it three-dimensional. And that makes it a polyhedron. But there are some cool pictures right there of all types of different polyhedrons. All right, a face is a flat surface. An edge is a line formed by two faces. So here's what I mean so far, and I'll show you this in a second, but a face is a flat surface. An edge is a line formed by two faces, and a vertex is the point where two or more edges meet. So there's the face, there's the edge, and there's the vertex. I think the only one of these three that's kind of hard to remember is vertex, because that's just not a word that we come across very often. But you guys all know what a face and an edge are. A sphere has all of its points the same distance from its center. Let me go back there so you can look at that. If you think about the center of a sphere being way in the middle where you can't see it, in the middle of that sphere right there, and all of the points radiating out from that center would be the same distance. A cone has a circular base and a single vertex. Okay. So let's stop for just a second because we didn't really define base yet. We talked about faces, but we didn't talk about bases. Bases are faces. How confusing is that? But a base basically makes up the shape of something. In this case, it's a cone. So if you can imagine this cone, if you could see inside of it, there would be the base. It would be a circle. That's flattened out because I'm going to make it look 3D up here. But you know what a cone looks like, so something like that. So the base of the cone is circular, and it has a single vertex. Okay, now we're going to talk about pyramids and prisms. And it's really important that you memorize what the difference is. A pyramid has only one base, which may or may not be a triangle. All the other faces are triangles and meet at a vertex. So if you're thinking about pyramids in Egypt and you're thinking about how they come to a pointy top, that might be one way you can remember it. Here's the deal though. Pyramids, like our notes say, don't have to be triangles. So that is not going to be an attractive base. Let me fix that really quick. So when you have a a pyramid, you might have a rectangle at its base, but as long as all the other faces meet at one vertex, like this guy right here, that is still a pyramid. That's actually called a rectangular pyramid right there. We name pyramids and prisms for their base shape. So this one's a rectangular pyramid, just like these guys down here. These right here are triangular pyramids. The reason they are triangular pyramids is because their bases are triangles. So again, we name pyramids for their bases. These guys are rectangular pyramids, and they are named that way because their bases are rectangular. These guys right here are pentagonal, or this guy, I'm sorry, there's only one of them. This guy's a pentagonal pyramid, and that's because its base is a pentagon. And then this guy right here is a hexagonal pyramid because its base is a hexagon. Okay, so now we know what pyramids are. We need to talk about prisms. So a prism is different. A prism has two faces opposite each other that are polygons of the same shape and size. So while a pyramid has one base on the bottom with all of the faces meeting at one vertex, a prism has two faces that are polygons of the same shape and size. So pretty much they're not going to have a pointy top. But here are some examples. Here are triangular prisms on this edge of the page. You can see that both of these triangular prisms have two opposite bases that are the same shape and size. Here are some rectangular prisms. They also have two opposite bases that are polygons of the same shape and size. One is a cube, one is a cuboid, but we'll get to that in a second. Here is a pentagonal prism, and here is a hexagonal prism. So you can see the difference just by looking at these, but it's super important that you memorize the definitions for both of those terms. Pyramid is going to have all of the faces come together at one vertex, so it's going to be pointy basically at one place, and then prisms have two polygons of the same shape and size. So they might be rectangulars, they might be triangular prisms, they might be pentagonal prisms, they might be hexagonal prisms, they might be, who knows, octagonal prisms, all sorts of options. All right, with triangular prisms, the bases are triangles. In pentagonal prisms, the bases are pentagons. And the faces of prisms and pyramids are polygons. So let's just remind ourselves what that means really quick. So in a triangular prism, it has two triangles that are the same shape and size for each base. Pentagonal prism, two pentagons that have two polygons that are the same shape and size for its bases. But it says here the faces of prisms and pyramids are polygons. Okay, so that's a little bit confusing, isn't it? Because again, what's the difference between a base and a face? So a base is going to be the polygon on a polyhedron that is outlining the shape of the polyhedron. A base is one of the faces, or both bases are two of the faces. The difference is, let's just take a look at our pentagonal prism right here. This pentagonal prism has 1, 2, 3, 4, 5. It's hard to illustrate this. 6, 7 faces. So all of the flat surfaces on that polyhedron are faces, but there are only two bases. There are only two pentagons within that pentagonal prism, and those give it its shape, and that's why those are the bases. All right, let's talk about cubes and cuboids. A cube is a three-dimensional figure having 6 matching square sides. So the big key with cubes is that all of the sides are the same length. You guys all know what a cube is, so I'm not going to really spend any time there. A cuboid, though, is a shape approximately like a cube. If the upper and lower polygons of a right prism are rectangles, then the prism is a cuboid, also called a rectangular prism. All right, don't get caught up in that like mathy definition right there. Basically, for something to be a cuboid, it means that the edges are not all going to be the same length. It's going to look like a cube, but the edges might be different lengths. So for example, in this little guy that we have in front of us, we have a square base up here, and then of course down here we can't see it, but we have 2 square bases. I'm assuming that these are right angles. But that those are right angles, and that this is the same, all of these sides are the same length. But then you have these other faces that are clearly rectangles. These are not squares. And so that's not a cube. It's a cuboid because not all of its edges are the same length. But it's still going to look kind of like a cube. So you can't just like take some random shape and call it a cuboid. I hope that's obvious. A cylinder has 2 congruent circular bases that are parallel. So here's a circular base, here's a circular base. Okay, now we're going to do a little textbook Toyo. So if you have your textbook, go ahead and open up to page 15. And obviously do this on a lined piece of paper because you're not going to write in your textbook. But go ahead and do that on page 15. I want you to look at the pictures that are drawn. And I would like you to write down on your lined piece of paper how many faces, edges, and vertices each one of those figures has. And then I think page 16 is pretty self-explanatory. But after you've done that, go ahead and come on back and check your work. All right, so this slide corresponds with your page 15 in your textbook. So let's look at how many faces, edges, and vertices are on each of these figures. So let's start with the rectangular prism up here on the top left. Okay, let's count the faces. We have 1, and then of course we have 1 on the bottom. You can't really see it, but so 1, 2, 3, 4, 5, 6. So there are 6 faces on that one. How many edges are there? Well, remember, these are the edges. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 edges. How many vertices are there? Let's see. Remember, vertices are where 2 or more edges come together. So there's 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices. All right, let's go over here to our triangular prism and count how many faces, edges, and vertices we have. So we have 1 face here. We have another down here. So 1, 2, 3, 4, and then we can't really see that back one, but 5. 5 faces. We have 1, let's see, let's start over here on the side. 1, 2, 3, 4, 5, 6, 7, 8, 9 edges. And we have 1, 2, 3, 4, 5, 6 vertices. Okay, now let's take a look at our, this isn't a triangular pyramid, this is a rectangular pyramid because we have a rectangle on the bottom. Okay, we have faces 1, 2, 3, 4, and 5 faces. We have 1, 2, 3, 4, 5, 6, 7, 8 edges. And we have 1, 2, 3, 4, 5 vertices.